Hello and welcome everybody, and well, good morning, good evening, good afternoon, depending on where you are, and thank you for joining Discovering Neo4j AuraDB free with Michael and myself. Hi, Michael.
Hello, everyone. How are you doing? Hope you're all well, and hope you're feeling better this week, Alex.
I feel better this week. Maybe you can still hear my throat sore sounding voice, but it's getting there. I'm looking forward to being back on my feet fully in a couple of days.
Super happy to hear that. And this week, fortunately, it's also a short week.
Yes.
So for me, it's only
less talking.
3 days. Exactly.
Yeah, for me as well.
Yeah. And so that will help as well. Yeah. So how was your weekend? Did you play any Zelda?
It was what? Sorry.
Zelda came out.
Zelda. Yes. I don't have a Switch. I have. I don't have one, so I'm not. I played the Diablo 4 beta though.
Okay. Yeah, that's good.
Yeah.
Was it good?
It's good. It's fun. Yeah, I didn't want to spoil myself too much. So I played one class for a couple of hours. Druid. It was very fun. So it's like Diablo's supposed to be. It felt right at home. So it's I'm
nice.
Yeah.
Happy
it's
to
gonna be fun when it comes out in June. Yeah.
Yeah. Cool. Nice.
And then I watched the ESC Eurovision Song Contest on Saturday.
Yeah, I wanted to watch this on Saturday with my girls, but I was stuck in a train for too many hours, and then I came home.
Oh no!
Came home only like at midnight after being on the train for. Actually, it was more than 14 hours now that I realized it. So I left the hotel at 5 in the morning to catch a train, and then I was home at midnight from London.
Oh, that's a long time.
So I was at Devox in London, which was good, kind of meeting people and everything, but the train was not so good this time. Yeah. So I missed ESC, so we still have to watch it. But perhaps, we did European Song Contest last year, and
we did,
I'm not sure if we have the blog post around. I think so, right?
The blog post, I don't know, but I have the YouTube link, which I can put in the channel.
European Song Contest.
So
let's see.
Here it is.
I wonder if I wrote. Yes, I'm not sure if I remember if he wrote a blog post about it or not. But anyway, the YouTube link is good.
Yeah.
Yeah. So if you want to add this year's songs and winners, then feel free to give it a try. As such, I saw someone writing about the ESC that it kind of unites people in some fun way, right? So,
yes.
Kind of everyone is fevering along and kind of hates on the commentators and but it's a good spirit and lots of fun.
It's lots of fun, yeah. I think
if you don't take it so seriously, then
exactly, don't take it too seriously because otherwise, I think. Actually, why talking about seriousness, I have 2 Neo4j logos here. Get rid of one. That's good. and it's like very casual. It's gonna be very fun.
Exactly.
Hi John. Hi Eshwar. Hi Luca.
Hi, Luca.
John teasing us with sunny UK. I mean, I look outside the window and it has just rained a lot. Now it's
same here. So we just had a downpour, like it was raining cats and dogs, and but in the morning it was actually nicer as such. So, but the UK was actually much more sunny last week than I expected. When I left on Tuesday, here like the week was meant to be all sunny all week, and in London it was meant to be all rainy all week. But then when I was there, actually I took the sun with me, I guess.
That's good, because it was not really good. It wasn't really nice weather last week. It was it's so still not very warm. It's really weird. It's like middle of May. And I'm still have to. I mean, I was wearing a scarf last week. Believe it or not.
Yeah.
Well, maybe because my throat. Okay.
Yeah, because of
but still, it wasn't super warm. So
So, and we got a question from Luca, which I can probably answer really quickly, and then we go into the session. So Luca is asking if you can use VPC virtual private link on GCP to connect his Redis database with Aura. So in general, AuraDB supports virtual private links, but only in Neo4j Enterprise. So I think I'm not sure if you can do it outside of these services, that you basically pull them all in the same network as such. I know that for Neo4j Enterprise or AuraDB Enterprise, it's supported that people can use private link setups on all cloud providers, so that it stays in your basically private network. But I'm not sure if this works for AuraDB Pro as well. So Luca, you can also just open a support ticket with the AuraDB support folks, and they can help you with that as such.
Yeah, I think that's probably that's a good point. I'm not sure if it works on Pro. I know that on Enterprise it's definitely a feature.
Yeah.
What could be another option if you want to look at is, but obviously you wanna use Aura if you wanna deploy yourself on, if you have already
it's also on the
your
cloud
own
marketplace.
deployment, exactly, on the cloud marketplace. So if you have already an existing cloud deployment, you can add Neo4j to
your
that
project,
to your project, and maybe that makes it easier to be closer integrated. Yeah.
Good point. Cool. But otherwise, we can get started, I guess, with today's topic.
Well,
right?
not quite.
Oh, not quite. Alex, good point.
Yeah.
I almost forgot about Notes. We should start wearing Notes t-shirts, right?
Yes.
So that's actually something that we should do, so that we don't forget about it. And should send out a few Notes t-shirts to the team. Also, promoting the conference.
So it's happening. Call for papers opened a couple of days ago. So we look forward to hear from you. No matter if you are, and this is the tagline, beginner to expert. It all connects here. So that's supposed to tell you, no matter what your experiences are with Neo4j, no matter what you want to talk about, we have a place for you at this conference. Or no matter what you want to listen to as well, obviously. So it's for all kinds of people. So if you have a beginner talk you would like to present, then submit the talk. If you have something very advanced, present the talk. If you have something super niche and special, also submit. There might be a way for that as well. Place. So call for paper is open until end of June. So you have a couple of weeks, and the event itself is in October.
Yeah, and we already got some submissions, which is great. We actually want to select early some speakers. So if you hand in your submissions before the end of May, then you might be in the early crowd that's been selected.
Yeah,
and in terms of topics, so our main areas are building modern applications and APIs with graphs. Of course, then AI and ML topics, and data visualization as well. Also, if you have anything in these areas, feel free to submit, but also if it's outside, just submit and we'll see where it would fit as such.
Yeah, if you've got something cool, we'll find a place.
Yep, exactly. Cool.
All right, I think we can potentially dive straight in today. I don't think you have to go over what is Neo4j AuraDB. I think we can skip that today. Let me move over to your screen here.
Exactly. So actually, let's not start on this page, but let's start here. So if you know me and know us, then you know that I've been playing around a lot with LLMs and GPT and Bard and others. By the way, Bard is not available in Europe, only in the UK. And 180 other countries, but all the European countries have no Bard access because Google is just skipping Europe. Interesting. Anyway, so in OpenAI ChatGPT, in the future, when you're kind of off the waiting list, so we are still on the waiting list, so unfortunately we can't show it to you in real time. But what you will be able to is basically to use plugins for GPT. So basically what it will allow you to basically do, connect to other data sources, run Python code, and other things as well, upload files and other things. And which is something that's really interesting, because then basically the LLM can be extended with more data sources, but also interacting with other places to trigger actions and so on. And what was really interesting is last week, where do I have it actually? Some other here. No. too many tabs in. Now I have too many spaces in Arc already as well. So Ethan Mollick, who is a database professor at Wharton, published something that was really interesting. So he is not a data scientist or so, right? So he basically just said, okay, I want to use GPT with plugins to try out a data set and make sense of some data, right? So he picked a data set and says, give me interesting graphs, right? I have a CSV data set with superheroes, give me interesting graphs. And then basically ChatGPT analyzed the data sets and basically said, actually it starts on the other one. Yeah. It basically said he uploaded the data set, it figured out what's in the data set. As such, do you have another data set? Okay, he had another data set of the superheroes. And then he basically said, okay, what kind of interesting analysis could you do on this data set, right? And it basically says you can do correlation, ability analysis, gender alignment, publisher analysis, and so on. I want to see something that involves math. He said, right? So, and then he said, the Skynet said we can do network analysis of superhero activity and abilities, right? And so degree, between centrality, closeness, clustering coefficient, and so on. And he said, yeah, let's do that. And then he basically let's go. And then basically with these plugins enabled, it was able to load the data, turn it into visualizations. First, some charts, but then also the network and looking at the centralities and degrees and so on, right? And looking at different abilities and other things as well.
Cool.
Right? So, and Alex, you and I were talking about this, and we said, okay, but this is all happening in a black box, right? So you don't actually know how it correlates this data and how it turns this data into this graph network and what it does there. And so we thought, why don't we take the same data, but basically look behind the scenes of the black box and try to do it actually with a graph database and look at what this data would look like if you import it for real into Neo4j. Right? So Ethan also published which dataset he used from Kaggle. Sorry. So it's here also in the link. So actually I can probably paste this in here. See if this works. Yeah. But I looked at the data set and it doesn't have the information that he mentions. It has like a bunch of the attributes like name, gender, eye color, and so on, but not something on the abilities as such, right? Although there's a second one. Oh, that's probably then the one that we can use. So this is flight, agility, hero names, but it's not all columns. Oh, I think it's the same data set that I have downloaded here. Right? So it has like hero name and then superhero powers, right? Power augmentation. So you see that it's also machine learning data set because it basically turned these abilities into one-hot encoding. So basically it's one column per data set.
I see. Yeah, okay. Well,
per ability.
Yeah, okay.
And then somewhere in the whole thing is probably an aggregated version of it, right? So this is kind of really good for machine learning because if you basically want to train a model on this, then basically these one-hot encodings are really helpful because then it doesn't turn agility into 5 and accelerated healing into 7, and then it thinks that 7 is better than 5 or so, but we do either true false, basically it exists or it doesn't exist, right? So, and that's what it is good for. So, and because this data set is a little bit annoying from that perspective, I didn't want to basically deal with all these hundreds of columns, 168 columns. I found another one, which is this one, which is very similar. So it has also 2 files, or actually it's all in one file here. It has the name, alignment, alter egos, where is the superhero born, who's the publisher, information, gender, IQ, intelligence, is it a leader or not, place of birth, and it also has the universe that they're in. And then here's this column with superpowers, which is basically comma separated lists, right? So which is easier for us to deal with. I mean, we could deal with the other one as well, but I thought this is just easier to manage than the 168 columns, right?
Yeah, probably.
And So and also history and other things, right? So I thought we can just take this one and go with this, right? So to go for it, we just go to Neo4j AuraDB. You can sign up and sign in and create an empty instance. That's what we're gonna do. We download our information here for the credentials and click on continue. And while it's spinning up the instance, we can rename this into superheroes.
And all the links are in the video description as well. Once I can add them into the video description on YouTube, but I'll post everything in chat as I.
Exactly. Super, thank you. Right. So we want to basically take the data set and turn it into a graph and see how far we get and what we can kind of find from it. If you have a little bit more time, we can probably also look at the other data set and show you how you would deal with these many columns in the Query language cipher as such. So that's also an option. And I thought we can also do a dashboard because to show some of these charts as well, we can actually do a dashboard as well from this. Right? So the other thing is, by the way, I watched Guardians of the Galaxy 3, and it was really good. So it was really harsh and brutal and so on, but it was really good. So if you have not seen it, definitely have a look. It's probably a little bit too tough for small kids, but it's a really good movie. So I can definitely recommend that.
Gotta watch that then.
Right. Yeah, do it. It's really, really good. So I mean, there's not only the Marvel superheroes, right? There's also like DC and lots of other superhero universes as such. So there's a lot to pick from. Actually, if you look at this database, by the way, the dataset set it scraped the data from the superhero database. So there's a superhero DB. Also a cool product name. And then you can basically look at characters and other things, and then it has like hundreds or 40,000 superheroes. So that's like a small town of superheroes and villains. Actually, that's the villains as well. Right?
Yeah.
So
you need a villain to be a superhero.
Actually, we can probably look into if you can pair villains with superheroes. So I'm not sure if the villains are in the Kaggle dataset as well, but then we can see which ones have the same powers or so, and which one can fight against each other. So
yeah.
Okay, let's see. So our database is our database is now running. So we can just click on the open link, and for the credentials that I just downloaded, I open the file and copy password from the file. Put it in. So soon we will have SSO, and then we don't need to do this anymore. And then it's actually as simple as going to the import tab and adding our superheroes file. Here's my superheroes, and this is 50 megabytes of superhero information, right? Which is quite a lot. So our initial node is already here, so we can call it hero, right? And then the question is, what do we want to do, right? So I mean, we will probably add a lot of the information, but we probably also want to pull out some information. So let's see what do we have. I think the base is something that we can pull out, like where are they based as such, right?
Okay, I was just wondering what base might be, but yeah.
Then creator, we can probably also pull out creator.
Yeah.
Created by, so we switch direction like this.
Mm-hmm.
So what collection, perhaps, right?
Yep.
Which collection? Then universe is probably also.
Yeah, I don't see
collection. So eye color and so on. We don't need formally IQ.
We could put it as a property if we wanted.
Yeah, we put it as a property. I just want to look at what do we want to pull out as an as a place of birth could be interesting, but probably there might be not too many.
Species might be interesting.
So relatives is probably, I'm not sure how well this is structured. You see that it's already here a 2-line thing. Species is good. Yeah, that's a good one. Species. Species. Whatever else. Superpowers. Superpowers is something Unfortunately, because it's a comma separate list, we can't pull it out yet. So we basically do it
I see that it is. Yeah, I can see here.
in as a post-processing. And then probably universe. We could probably pull out universe.
There's the universe. Okay. C17S. Okay. I don't know what that means.
So this is kind of the context of our hero, right? So that's what we have as semantic context of things that are also shared between heroes, right? And then we say add from file, and we select all, and we just exclude the ones now that we.
You're in the species node. Do you want to be there?
Sorry, no, I don't want to do this. Good point. I want to do this on the heroes node. So select all, and we exclude the base collections creator. You have to help me, Alex, so that I don't miss anything.
Yeah,
species and there universe, I think, right?
Yeah.
I think that's it. So the question is also is the character, or here full name has no entry, so we probably go with character here as the ID for.
Yeah. I think character should be the definitive.
Okay, and then for the other ones, we can map the one attribute that's there, and it should automatically check off all our stuff.
This is new.
It's really quite nice. That's new, exactly. Creator, so it becomes much faster here, right? So we can just. Which one was this? Collection.
So
we can.
It's much faster, but it's also more visually clear with the check marks.
Yeah. Also, you can probably get in a forest of check marks and stuff if you have too many. Species and universe. It's the last one, and then we map them all, right? So everything is green. So this is basically our data map, except for the abilities, right? Which is actually the thing that we didn't want to add.
No, but we can do that later.
Exactly. So if you click on the run preview, it will sample a few lines from the file and turn this into our graph. And here in the middle, we see actually, so the non-node is probably very, that's actually something that we can exclude. So here in settings, we can exclude none as an, it's a field that we don't want as an empty. If you run import again, hopefully there should be non-node. Yep. So this looks better, right? So here is created by, based in, Warren Kenneth War, and from Earth, universe Earth B, or something like that. Another universe, mutant, more universes, right? So it seems to be a good enough graph, right? So human as a species has a lot of members as such as well. So it seems to be pretty okay, right? So what's the green one here? Alignment, alter ego is non-character actrice. Okay. Looks okay to me. Do you see anything that's kind of off kilter?
Oh, it looks good. I mean, there were a lot of lonely nodes on the outskirts of this.
Yeah, but that's probably just
that's probably the ones that had
sampling. Yeah. So what are the blue ones actually? The blue ones are collections. That's probably just collections that had no connections yet or something like that.
Oh, okay, interesting. Yeah.
Which is interesting, right? So because collection should also have an in collection. Okay.
Yep.
Let's see. It's 50 megabytes, so it should take a few seconds to import. But while it's doing that, we can look at. So it should probably take, a minute or something like that. But while it's importing this, actually, we should already see, if we refresh this one here, we should already see the first ones coming in, right? So we already have things like, so here we'll probably pick character as the name, right? So everyone every character also has a name here, right? So all the A characters and B characters, basically, right?
Yes, of course, because alphabetically.
Starting with this, and then right now it doesn't have relationships yet, right? So it's still importing nodes. But so we see now collections, creators, heroes. So we can also look at what kind of collections are here. What kind of bases, right? So because you were wondering what's the base thing. So you have Gotham City,
Okay,
America,
that's
Timeless
nice here.
Halls, Seattle, Washington, Malfoy Manor. So it looks like Harry Potter thing.
That's a Harry Potter thing, yeah.
Q-Ward, Antimatter, Ur, and so on.
Yeah.
Oh, it's done. Nice.
Oh, that was
a minute for 50 megabytes. So it created in total 11,000 nodes, 1,000 nodes, 110 nodes for creators, 2,000 collections, 94 species, 898 universes. That's a lot of universes.
Yeah.
So in total, we have 11,000 superheroes in there. So it's not the 40,000 from the superhero DB, but perhaps the villains are not in there, right? So it could be that the villains are missing.
Could be, yeah.
Okay. So if you now click on Explore Results, we actually get to the Explore tab. So imagine we don't know how to write query language cipher or so. Then it gets us into Explore tab, and we can already see like similar like we had before an example graph. If you clear this out with clear scene, we could also say we just want to see, for instance, hero and base or something like that, right? So we would see the heroes and the bases. And you can zoom in and probably fold this away. And then you see that there are a number of bases like Man Cave, formerly Monster Isle and Titan. Okay. His ship, Gantu.
Okay.
Metropolis, Manhattan, New York City, New York,
Yeah,
right? And
a little bit more.
then this is probably Gotham or Earth or something. Mobile. Okay, basis mobile.
Okay.
So we see a bunch of bases: San Francisco, Cybertron, Egypt, Burnside, Gotham City. So you see there's some overlap and some that are not cleaned up well enough, so they don't, like Shield Helicarrier, right? So that's one of the Sharon Rogers, one of the Avengers. But this is kind of how we can explore this. And now we could say, for instance, we take these heroes over here, select them and dismiss the rest. So we can say dismiss others. And then for these, we can say expand. Or first of all, we can probably zoom in. And then say expand, and we can, for instance, say we want to see species.
You picked hell. Right? Okay, cool.
Yeah, so species spirit. So it seems that there's no caption for this, so we can probably pick at least the text. Why doesn't it show the caption then? That's weird.
Didn't it?
Okay, because you were not zoomed in enough. Okay, that was the reason. So demons. Yeah, Good Omens 2 is coming, by the way. So that's why we have hell and demons and so on,
okay.
so, which is really great. So I'm really excited for Good Omens 2. God Eternal, Lucifer Morningstar. So that's the DC Lucifer Morningstar series, right? And then we can basically take from here. We could also say they're probably all from the same universe. So we would say kind of this is the Spawn universe, right? And from the Spawn universe, we can collect to the other nodes. That's the other ones that we have here, right? Or there are actually even more, right? So and so you can basically expand and navigate through the data. You can also pick two random nodes and say what's the shortest path between them, and then it will basically find us the shortest path. And in this case, it's actually the creator, right?
That makes sense.
Right, who connects them, right? So there's lots of stuff that we can do with the visualization here. But I think we wanted to look into these abilities, right? Remember, we had these abilities in our heroes. We have all these attributes now, like alignment, character, kind of class value. By the way, it automatically converted these numeric things into numbers and stuff, right? So these are now automatically from the CSV converted into numbers. I think we still miss a config option that replaces really something like none. So in general, with empty, right, or dashes. So that's something. Yeah. So it didn't use it for IDs. So that's the setting that we just used before. But there's still something missing that kind of really just skips the value as such, right? So if we wanted to, we can go over the database and clean out everything that says none as such, right? So we can basically say, go to all nodes. And actually, is this? Oh, let's ignore this for now. It's a little bit more involved. Person on speed 80. So, but it's not created a node for these. Velocity, and here are superpowers, right? So superpowers is a string with comma separation, right? And that's what we want to turn into nodes, right? So that means we take our heroes and return n dot superpowers, right? And if you do this, you get like these strings, right? So you have like these comma separated ones. So what we can do with these superpowers is we can as powers we can split them into split our hero and we split the powers by comma power. So and then we can return power limit 25. So this gives us now a list for each of them, right? So which is exactly what we wanted. We can probably trim them, but it seems to be pretty good as such. And then we take these lists and unwind them. Unwind turns the list into rows. So
should we create a index, a unique constraint?
Oh yeah, that's a good point. Create constraint power name, something like that, right? If not access for p power require p dot name is unique, so that we only create each power once, right? Point x. So so here we now take our powers, this list. Actually, you can probably inline this, so we don't have so many lines here. So we split the powers and unwind powers into a power. So and when we now return this, it gives us one per line, right? We can also return, for instance, n dot. What was this character, right?
Dot hero. You mean? Oh, I mean what you mean.
Character. It would repeat each name multiple times, and then we see basically all the powers that they have, right? Super. And what we want to do, we want to ignore the ones that are none, right? Where we are not power equals none. Right? We don't want to have the non-powers because that's kind of placement. So and then we basically say we create a node for the power, p power. Name is power, and then we connect our hero, this n here, right, for the hero, and then just has power and then p, right? So that's how we can take this list for the hero. So you see the name pops up multiple times, and we just, if the power node does not create for this one, then we create a new one with this line, and then we can connect them to the hero as such, right? And then we don't return anything. We just let it run, and hopefully it should be not too much, and it should create a bunch of. So we have 16,000 nodes, 37,000 relationships. Yeah, so it created 325,000 relationships. So we were close below the limit. and 477 nodes. So many heroes have a lot of power. So it seem to be really like superheroes, not just superheroes, but superheroes. Right?
I think it's more seemed to me like more of a collection of attributes, almost like when you had Alucard open with dark power and blood magic or what it was. It's more like.
Yeah, but it sounded quite a lot, right? So should we actually look at which? So actually, let's look at the has power, right? So it has like Alucard, as you said. Alucard seems to be a very powerful hero, right?
I think that's the
blonde male, white privilege person.
That's Dracula.
Right. So Konami is creator, the vampire. Okay.
Yeah, it's the Alucard is Dracula backwards. It's like
okay.
this
Nice
thing out of Castlevania.
It's human. Okay. Human and vampire.
Yeah.
Okay. And from 2 universes, Castlevania and C17S and ML. Like from 3 universes. And then this creator, Konami. Okay. So very powerful, right? Curse resist, berserk mode. It sounds almost like an RPG,
exactly,
dexterity, agility, and so on. Right? But let's see. What we can now see is basically who has most powers, actually, right? So should we actually check which hero has the most powers? And we just return the hero or the hero character. And then we return count of hero has power, which is basically takes the degree of the node as powers. And then we just say order by powers descending limit 5 or something like that, right?
Mm-hmm.
So this is the pattern that spells out a hero has a power, and count basically counts them in line as such. And so we have Knall and Grimgoth and Circle Kun, which have like 280 powers.
Okay.
Hasimal, Ben 10,000. Oh, these are like all pretty good. And there's also Ben 10, right? That's the small baby brother of Ben 10,000 or something like that. Okay, so we're making fun of some hero franchises and people will hate us for it. But so we're also the people with no powers. Also, Batman has no powers, see? Easy. Batman can only drive and jump and shoot. There's even
Baba Yaga seems like, I'm not sure.
Baba Yaga is also, because Baba Yaga can do magic and all kinds
exactly. I
of
think
stuff,
that's
right? So weird. So it's probably data quality problems.
Yeah.
We can actually look at where the power is greater than 1, where powers is greater than 0. I mean, let me return insert character powers. So Betty Cooper is 1. Cypher. Cypher is a superhero. Okay. Good to know. So Captain America Infinity Gauntlet has only 1 power. So you probably need to merge all the Captain Americas to get some more powers.
Yeah.
Okay. So there are some extremes in both directions, right? So, but the this looks really interesting. 280 powers. Crazy. Should we just try to bucketize them and see kind of how many superheroes are with which kind of power? I want to see this.
Yeah.
Which is actually quite nice because what we can do is basically you can just say with powers, if you bucketize them, we can divide it by 10 and do times 10. So it's like 0, 10, 20, and so on, right? And then we just as heroes as power 10. And then order by power 10 descending, right? So basically this takes the powers, bucketizes them into 10 kind of 10 decimals, and then counts how many heroes have so many powers, right? And then we order it just as this. So we have 4 of our 11,000 heroes, 4,800 have no powers, okay? 1,500 have 10 powers, or 0 to 10, 1 to 10 powers, which is probably most realistic, right? So then 1,300 have 20, 40, but it's pretty distributed, right? So it's still 100 people have 100 powers. So that's a lot of powers. Crazy. And then 70 people have more than 240 powers. That's then, oh no, that's actually not all pages. Oh, no, 25 of 25 results. Okay. 240 powers have only 17 people.
That's crazy.
Okay. That's interesting. Cool. What we can now do is basically we can match up heroes, or we can also look at which powers correlate as such. So what we can
maybe we could find which powers correlate to find out which are the most the top, maybe the 10 or so top most common powers.
Yeah, good point. But before we do this, I want to do something else, which is is this here? No, here. I want to collect distinct here dot the universe where they're coming from. Not the universe. Is it the universe or the species? What do we want to collect?
I don't know what you want to collect. Hero species, yeah, species could be good.
I want to see kind of which races or which species have the most all these powers, because that sounds so crazy.
Then we should do species.
So let's see if we can. We can probably do it just like this, and then start species. Probably not. Probably fail. Oh no, actually. So the people with not a lot of powers. Something's wrong now. Here, return. I think we need to do this earlier up here. And then we need to flatten them into a map. So it's a little bit, I want it to be really easy. So let's just use, just pick one here and then collect distinct species. So this picks just the one species of a person. If they have multiple species, we just ignore this for now. And then we get the distinct ones per power, basically, right? So okay, the small powered ones are all kinds of people. What I'm more interested in is like these high powered ones. Okay, so you see gods, demigods, cosmic entities, as guardians. So, and vampires, of course, right? Vampires have probably also sparkling as a power too, right? So Kryptonian, Olympian god. So like everything. So you see, there's a lot of demigods and gods here, right? Kree. Okay. So the humans are probably at the lower end here. And then it starts with more with gods and stuff like that. Yeah. Okay, so I just wanted to check who has all these powers and such. Okay. But what we wanted to do as well, we wanted to correlate them, right? So we have one hero which has a certain power. And then we have a second hero which has the same power, right? H2. And now we want to see how often. Oh, sorry, no, that's the wrong direction. So that's actually correlating heroes by similar powers. So we can do this as well. We can say with H1, H2 count star. So how many powers do they share basically?
Yeah.
As common, right? Return.
Didn't we want to
H1.
do that?
Yeah, we can do it and then we flip it around for the other thing, right?
Okay. Yeah.
Common order by common descending limit. Say 50. Actually do this up here already, so it doesn't need to do so much compute. So, and it basically takes all the heroes and correlates them via their power. Right. So let's see. It's expanding quite a lot because these powers are also supernodes, which have a lot of, up to 11,000 things. You should probably look at an explain plan here for this one and see. And it does 2 label scans, a hash join, and then it has like 6 million rows, 6 million rows, and aggregates it together. And so our little free instance is a little bit overloaded probably by this. But while this is running, we can probably do it the other way around as well. So we said we have a power 1 that is an hero has, and a power 2 that an hero has. We wanted to see which powers come in pairs, basically, right? P1, P2. And P1.name, P2.name, and common. So, good question. So this seems to take longer than I wanted. What we could probably say is we can limit it by powers or heroes that have at least a certain number of overlaps, right? If it's only one, it's kind of pointless, right? If there's only one overlap, then it's kind of pointless. So what you can say actually here is we can say we want to have only heroes that has have at least, what would you say, 2 or 3 powers?
Yeah, well, I would have said even at least 5 maybe. So
let's say greater than 4. But it's 1, that's 2. 2. Then we can just find them here and we start this whole thing again. So it should touch much less data as such. So we can actually profile. That's heroes that have at least 4 powers. We could have actually, just to test it out, let's say heroes that have 20 powers or something like that. Because then this should remove these and leave us only with 5,000 or something like that. So let's see what happens. And then for the powers, this is basically the reverse. So the powers that have... Actually, that's a good question, Alex. Let me just put this into an input file. I have not looked at the powers themselves, kind of how frequent are they, right? So I wanted to see kind of which powers are really frequent. As here, heroes, order by heroes, descend limit. So agility, endurance, reflexes, stamina. That's the typical RPG. Accelerated healing, cold resistance, heat resistance, weapons master, durability, master arts, artist. So intelligence, okay, fire resistance, which is not the same as heat resistance, it seems, right? Toxins, disease, super speed. Didn't we have just super speed somewhere as well? Or was it just speed? Super strength we had. Jump, dexterity, flight, acrobatics, regeneration. So we have a lot of generic powers, basically. And then we can look at what else is coming there. Let's say limit 100 or something. Electricity resistance, fire control, force fields, soul resistance. Okay. And in the other direction, which powers are really rare? The gray, intimidation. only one superhero has intimidation as a power. Or superpowers.
Okay.
Sailing, not matching of the superheroes.
This is not a real.
Nova Force, okay.
Singing.
Okay. Also not good.
Rare superpower.
Oh man, crazy. Swimming. Oh, that's also dangerous for superheroes, right? If they can't swim, then
well,
that might
if
also be.
swimming is a superpower, we are all superheroes, Michael. Did you know that?
Oh, that's good. Yes. Good point. And leadership. Also, not a lot of them have a leadership power. Right. Okay. So that's an interesting set of powers that are not so frequent. So, but I think our little database is a little bit overwhelmed here by this.
You want to quickly say why you tried profile here and explain the other one? What's the difference?
Oh yeah, explain just shows you what the query would look like. That's running really quickly because it basically just computes the query plan and says this what would be executed. And profile does this as well as actually shows you in the actual how the query runs, how much data is actually touched and accessed as such. Right?
So this is an estimation. If you do explain,
that's an estimation. That's why it says estimated, right?
Yeah.
Here.
But you get at least a good feeling about how if a query is complicated, then at least you get a feeling of is it truly complicated or is it truly touching a lot of nodes. And if you do profile, it actually runs and gives you the results as well, how many data points it touched.
Exactly. We could probably also say here we only want to have powers that have certain number of heroes in there. So what we can say is basically has power. We say this is perhaps between let's say we should want to have at least of our heroes at least 500 or let's 200 heroes have this power and not more than 2000 because then it's too common or something like that, right? So that's another thing that we can look at as well. Not sure if this helps a lot to cut the data down, but that would be another thing that we can do. But it's probably just a small instance that's overloaded with like pulling all the data into memory and expounding into that as such.
Yeah.
Right. I mean, what we can do probably here is we can just return. This is just an cross product alone, so that's already how much? 22 million rows between them, and then there's basically the cross product that always has to check. We can probably do using join on P, so then it tries not to do the query across the supernode in the middle, but tries to come from both sides as such. So let's see if this helps at all. But it can just be because the instance has not enough memory that it runs into an issue here. And so let's see. Cool. But what we can also do is basically we can also correlate heroes by other things, right? So we can basically say, if we say, for instance, which heroes have the same basis or something like that, right? So we would say, here's our base, and which other heroes are in the same base, basically, right? Headspace, is it headspace or something like that? All the other queries running. Oh, it's based.
Based, yeah. Based.
And this one is also based. I just remembered something. We also want to do dashboard. So we need to do limit 10. We would basically see which heroes share the same base as such, right? So we have like all these heroes on Gotham City, for instance, right? And then we could also do like skip 100 limit 20, still Gotham City, man. It's still Gotham City. That's really weird. Imagine that so many something's wrong here. Doesn't it adhere to the skip thing? Oh, it starts from the base. Okay. Or are there so many paths? Could also be that there are so many paths. Oh, okay. So it's just so many paths between so many heroes and Gotham cities that all pairs are kind of multiplying up to a large number. Okay.
It's an interesting comment from Max on the chat.
Mm-hmm.
Because I think we did that. Don't remember if you included the score of the powers. If so, then it would be interesting to see which heroes have the top 10 powers by score of power.
Mm-hmm. Good point. So we didn't include the score of the powers because, let me check here. In the we can actually look in the file here.
I think we did.
Here the score is not in this one of the powers. As such, it has for some of the powers. You're right. So for some of the powers, like omnipresent, omniscient, and strength and speed, it has like scores or like power in general in intelligence. So it has it for a few, but not for all of them. Combat, durability. So yeah, that's a good point. So
there's a power score. We could at least look
a
at
power. Yeah.
Power.
So what you can do, that's a good point, Max. You can put the property of a power on the relationship. So you would basically between the hero and the power, the strength would be. And so if you have power here, then here on the power relationship, we could add a relationship property that says basically something like strength or weight or something like that, right? And that's in float or integer or something like that, depending on. So we could basically do something like this here, and then we can use this in the computations as well. But our query also finished now. So we see these. You see it already from the names. They're probably from the same universe as well, right? And we didn't filter out inverse pairings, so they pop up everyone twice as such. So I'm not sure. So they're probably all from the gods and hell and whatever as such. But the plan probably also shows us that it did quite a lot of work, right? So 179 million rows joined here, right? So it's 200,000 times 200,000 roughly, or 200,000 times 300,000, right? So it's a big hash join, right? And then it needs to filter it on, and then that's why it took 1 minute and 30 seconds on the small memory instance here. So
little instance,
right? So that's kind of the reason. So, but we have a few more minutes, right? So we can show how quickly we can actually do dashboards, right? So and pick some of those queries that we already had in here. So Neo4j plus S, Neo4j, and our password is here. So like we had in the ChatGPT plugins, we can also basically do dashboards here, right? So we can basically say, this is my first dashboard, and I want to see just the number of heroes, right? Turn count star, and this is not markdown, but single value, right? If I do a save, it says 11,000 heroes, right? Here we could do a graph. So you would basically pick any of these and then turn it into a label, basically. So here we probably want to use character. So this would be an automatic graph from that, right? So patience. Then we can add more. So for instance, you can say this is kind of top powers or something like that, right? So we can basically say, give me the power. And we want to return p.name, count how often this power has power as heroes. And then we want to use it as an bar chart, for instance, right? Save. and this shows us the distribution of powers as such, right?
It's small, maybe.
So it truncated the results a little bit, right? But
yeah.
So this is kind of something like this. With advanced settings, you can also change legends and things and lots of fine-grained stuff, right? Okay.
I think you can make it overall a little bit bigger, can't you?
Yes, I can. So I can make this bigger as well.
Not that it helps much with these many values in this case, but generally, yeah.
Exactly. So what else can we do? We could also say if you want to see like the species distribution, right? So basically, we want to see how many species has, or how many heroes does each species have, right? So, and this is species hero, and we just return s dot species. So is heroes, and we want to turn this, for instance, into a pie chart, because pie charts are so great, right? So we can basically say, okay, everyone is human, and there's a lot of other people. Right?
Okay.
Demons, lots of demons, animals, and then probably gods, right?
What's the purple one or the pinkish one? And aliens. Okay. Okay. So, good.
Okay. Right. But then we can also say, for instance, what are the top powers for aliens or something like that, right? So if you have our top powers here, we can duplicate this one, right? And then we can say, for instance, we want to only do this for aliens, right? So if you say has power, then here's our hero, which we're actually not interested in this case. But we say species, and here we say species s, where s dot species equals alien. Right? This is now hopefully, yeah. So this is kind of the power distribution for aliens. So you would see death manipulation. We didn't order it, actually. That's something we didn't do. Order by heroes descending. Then it should probably become a power law distribution or something like that. Such. Oops. Something went wrong. 250 rows. Power.name.
You didn't specify heroes, didn't you? Oh no, here it is.
I did here.
Oh, you did.
That's weird. Power name, and then how many powers there are. That's weird. Good question. Limit 500. I'm not sure why it. Probably, you know what? We should probably do here an reaxis. And then P like this. Otherwise, it just funds the pattern. So each power would come up many times, basically, and then not one time. So this should hopefully be better. Yep. So this is now the proper power law distribution, right? So it starts at agility all the way down here to planet control. No, plant control, not planet control. Plant control. Yeah. Okay. Right. But what's now interesting is we can actually pass in this here as a parameter, species. And actually, I wonder if that's actually automatic. No, but what we can do here is we can add a selection. And so this is now an node property, species, and name is also species. And that's it already. And it's called NeoDash species. Okay. click, and then we can select this here. We can basically now say alien, and if we save this, it should adjust it. So if I now say human, and it shows me the power distribution for humans. If I say God,
yeah,
demigods, then I see the power distribution for gods and so on. So you can also basically with this configure your dashboard to be more interactive. Where then like all the queries that use certain parameters are rerun and will use selected parameters as well. Right?
Yeah.
So that's another thing
that's
that
super
you can
cool and super easy.
Yep, and you see that I completely are not good at organizing and sorting out things properly.
That's okay.
My stuff is all a mess. So we put a species selection in there. So then,
that's okay.
It's not much better.
It's like a puzzle game.
I think. Yeah, exactly. It's like these need to move stuff. So this is heroes. But this just was meant to show you how easy it actually is to create a dashboard in a few minutes, because we had only 5 minutes left, and now only 5 minutes over. So from that perspective, pretty good.
Right? Exactly. Yeah. And if you want to try this yourself, it's NeoDash. It's free under the Neo4j Labs program. So you can, I linked this in the comments as well as in the video description. And you can, as we just saw, you can use it with Neo4j Aura free. So you don't have to do anything. Just have Aura free running and use NeoDash with that. Or use it with any other Neo4j instance you have running. You can combine it with desktop. You can combine it with your other implementation. So that's exactly, not sandbox exactly easy. And you can quickly get some visualization, dashboarding, click together a couple of lines of code if you want to, and then you see the dashboard, and it's super helpful for explaining the content of your graph.
Yep, exactly. Cool.
Yeah,
that was good.
I think with the end. It's a fun data set. I think I like that a lot. That was I almost wanted to say real life. Obviously, it's not. but it's
good real life data set, exactly.
Yeah, exactly.
But just paste the link to the Kaggle data set as well into.
Yeah, perfect. Right. That's also in the video comments. Sorry, in the video description. And yeah, with that, I think we at the end. Thank you all for watching. Yes. Thank you, Michael.
Remember notes.
Remember notes, exactly. If you have any interesting presentations up in your secret chambers, then don't hide them anymore. Share them with the world.
Yeah.
Give it.
Be a superhero. Presented notes.
Be a superhero, exactly, in presented notes. And we'd like to hear from you. You have some time, so don't worry. But like Michael said, if you are submitting early, you will be the ones of the first that is visible on the Neo4j Notes website. So yeah, that would be great. And yeah, we will be back next Monday.
Yep, exactly.
Yep. All right.
Have a great week, everyone. Enjoy your time. Take care.
Exactly.
Bye-bye.
Take care, everybody. Bye.